So, welcome to all regarding to the continuation of sequence of modules on the soft computing techniques. Okay, so some other part we will discuss. We are at the special networks. Just recall the previous network. I want to share my screen. This is simulated annealing network, special networks, Boltzmann machine, Gaussian machine, Cauchy machine, probabilistic neural net, cascade correlation network, cognition network, neurocognition network, cellular neural network, optical neural networks, third generation neural networks, encoding of neurons in a system and in the simulated learning network, and that CNN is nothing but our cellular neural network layer sizing, deep learning neural networks, so extreme learning machine model. Okay, these things we will discuss. In the simulated annealing network, the concept of simulated annealing network has begun its origin in the physical annealing process performed over the metals and other substances. In metallurgical annealing, is a metal body is heated almost to the melting point and then cooled back slowly to the room temperature. This process is eventually makes the metal's global energy function to reach an absolute minimum value. The metal's temperature reduces quickly. The energy of the metallic lattice will be higher than the minimum value because of the existence frozen lattice um, dislocations that would observe the disappear due to the thermal agitation. So, analogous to the physical annealing behavior, simulated annealing can make a system change in its state to a higher change state, having a chance to jump from local minima to global or local minima. There exists a cooling procedure in the simulated annealing process such that the system has high probability of changing to an increasing energy state in the beginning phase of convergence. The beginning phase of convergence. Then, as time goes by, a system becomes stable and always move in the direction of decreasing energy state, as in the case of normal minimization procedure. In simulated annealing, the system changes its state from original state okay, to the new state by these probabilities function. Delta E is the E volt minus E nu. Okay. The figure in it is noted that delta E greater than always is higher the probability. Delta E is less than for any temperature. Okay. This is the probabilities function delta E for different values. Delta E greater than 0, delta E less than 0. Simulated annealing stone hill, local minima and global minima. The basic system configuration components in the annealing algorithm are the basic system configuration, move set, fast function, cooling system. Okay, the early optimization technique used in artificial neural networks is based on the Boltzmann machine. When the simulated learning process is applied, uh, the, the discrete Hopfield network, it becomes a Boltzmann machine. The network is configured as a vector of the states of the units. Okay, the Boltzmann machine consists of set of units, bidirectional connections between the pairs of units. The machines can be used an associate memory. Okay, it has an associate memory. So this is the function. Okay, this function is called maximum of a consistency function. CF is maximum consistency function formula. The maximum consistency function can be obtained by letting each unit attempt a change its state between 0, 1 and 0 or 0 and 1. The change of state can be done either in parallel or sequential manner. However, in the case of the description is based on the sequential manner. The continuous change. When unit xi changes its, this is the maximum consistency function, the formula. Okay, so 1 minus 2xi is equal to plus 1 when xi currently off, minus 1 xi currently on. Unit capital xi were to change its activations, then the resulting change in consciousness function can be obtained from the information that is local unit xi. The probability of the network that attempts change for units in xi is given by, this is the function. Okay, this is represented as the accepts a change. Okay, network that accepts a change, AF, that is represented with exponential. It's related to exponential, of course. Architecture of the Boltzmann machine. Just examine that architecture diagram with the different nodes, loops. Okay, testing of that algorithm of Boltzmann machine. Step 0. Initialize the weights representing the constraints of the problem. Also initialize the control parameter capital T and activates units. Step 1. When stopping condition is false, perform. Again, repeated steps. Step 2, perform steps 3 to 6 n square times. Forms of approach. Step 3, integrate I and j are chosen randomly values between 1 and n. Unit uij. Step 4, calculate the change in consciousness. Change in consciousness function. Step 5, calculate the probability of acceptance in change in state. Acceptance of change state. In step 6, we can decide R be a random number between 0 and 1 and R less than if we can accept the change. Okay, R greater than or equal to AF, reject the change. Step 7, reduce the control parameter capital T. Step 8, test for stopping condition, which is the temperature reaches a specified value or if there is no change of state for specified approaches, stop else continue. Like the Gaussian machine. Gaussian machine, that is the logic there in the Boltzmann machine. Gaussian machine. Gaussian machine is one of the includes Boltzmann machine, Hopfield net and other neural networks. The Gaussian machine is based on the following three parameters. Slope parameter sigmoidal function alpha, time step delta t, T temperature capital T. The steps involved in the operation of Gaussian net are follows. Compute the net of the new value, the approximate Boltzmann acceptance function, is obtained by integrating the Gaussian noise distribution. where xi is delta Tf. The noise which is found in the way logistic rather than a Gaussian distribution process. A Gaussian machine is identical to position in the metropolis reaction. Cauchy machine. Cauchy machine can be called as first stimulated learning. It is programmed including more noise to the net input for increasing the likelihood of a unit escaping from a neighborhood to a local minimum. Larger changes in the system's configuration can be obtained due to the unbounded variance of the Cauchy distribution. Noise involved in Cauchy distribution is called color noise, and the noise involved in the Gaussian distribution is called white noise. By setting delta t is equal to Ch, tau equal to Gaussian machine can be extended into Gaussian machine by it's the optimal boundaries between categories. It assumes the training that are original representative samples. The probabilistic neural net consists of two hidden layers. The first hidden layer consists of dedicated node for each training pattern, and second hidden layer contains a dedicated node for each class. The two hidden layers you should observe in the diagram. Okay, output layer. The first hidden layer contains a dedicated node for each training pattern, and the second hidden layer contains a dedication node for each class. Two hidden layers are connected on a class by class basis. There is several examples of class in first hidden layer are connected only a single machine. Second hidden layer. These are the first two hidden layers. Output layer. Loop we should be connected like this. Input layer. X1, X2, etc. Xn. They are hidden layers. The algorithm for the construction of net is as follows. Step 0. For each training input pattern x of p is equal to 1 to some p I value performs two steps. Create pattern zk hidden layer 1. Weight vector zk. Zk is either z class 1 unit or z for class 2 unit. Step 2. Connect the hidden layer 1 in the hidden layer 2 unit x of p changes class 1. Okay. Observe the diagram of the two hidden layers. Cascade correlation network. Cascade correlation network builds its own architecture as a training program. The figure shows cascade correlation architecture. The network begins with some inputs and one or more output nodes, but it has no hidden nodes. Each and every input is connected to every output node. There may be a linear units or some nonlinear activation function, such as bipolar sigmoidal activation function in the output nodes. During the training process, new hidden layers are added to the network one by one. For each new hidden node, the correlation magnitude between the network's nodes output and residual error signal is maximized. The connection is made each node from each of the network's original input and also from every coexisting hidden node. During time when the node is being added to the network, the input weights of the hiddens are frozen and only the output connections are trained repeatedly. Each new node thus adds a new control layer to the network. Just examine here. Different types of nodes here. Input, bias, hidden nodes. how they are added in the picture. Cascade architecture for two hidden layers have been added. In figure, vertical lines sum of all incoming activations. The rectangular box connections are frozen and zero connections are trained continuously. In the beginning of training, there are no hidden layouts. The network is trained for the complete training set. Since there is no hidden node, a simple learning node rule, video hacking rule, is used for training. After a certain number of training cycles, when there is no significant error reduction, and the final error is obtained in the unsatisfactory, we try to reduce the residual errors further by adding new hidden node. With a candidate node that receives trainable input connections from the network's external inputs and from all pre-existing hidden nodes. The output of this candidate node is yet to be connected to the activation active network. Several number of approaches for the training set. Okay, the candidate's node maximum is given by the function C as shown in the figure, where I the network output at which error is measured. The value C measures correlation between candidate's node output value and the calculated residual output error, like this. Alpha is the sign of correlation between candidate's value. C as the training single layer of weights. Combination network. The synaptic strength from cells X to cell Y is reinforced depend only if the following two conditions are true. Cell X is pre-synaptic cell 5. Second one is none of the post-synaptic cells are present near cell Y. Y is stronger than Y. The model developed by combination successor to the perception, which is perform combination of the symbols from any alphabet after training. Figure shows the correlation between pre-symptomatic and post-symptomatic cell. Pre-symptomatic and post-symptomatic cells, see, like this. To show the nodes, one input to number of outputs like this. That is a diagram pointing to pre-symptomatic, post-symptomatic cell. The combination network is a self-organizing multi-layer neural network. It nodes receives input from the defined areas of the previous layer and also from units with its own area, the input and output neuron. Elements can be formed echo positive analog values which are proportional to the pulse density of firing. Biological neurons. The cells in the combination model use a mechanism of shutting inhibition that a cell is bounded terms of maximum and minimum activities and is driven toward these extremities. The area from which cell receives input is called connectable areas. The area in which inhibitive cluster is called proximity area. Figure shows the model of combination. Is the connectable areas for cells in the same vicinity are defined to overlap but are not exactly the same. There will be a slight difference appearing between the cells which is reinforced so that the gap becomes more apparent. That this each cell is allowed to develop its own characteristics. Combination network can be used to so neurophysical activity and physiology. So since this network closely resembles natural characteristics of biological neurons, this is best suited for various kinds of visual and auditory information processing systems. However, the major drawback of combination network net is connector cannot deal with the problems of orientation distribution. To overcome drawback, an improved version called Neo Combination Network was developed. Neo Combination Network is again developed to eliminate some drawbacks. The combination rate cannot deal with the problems of orientation or distortion. Neocognition network is a multi-layer feed-forward network model for visual pattern recognition. It is hierarchical net comprising many layers, and there is a localized pattern of connectivity between the layers. It is an extension of cognition network. Neocognition net can be used for recognizing handwritten characteristics. The algorithm used in cognition neocognition is same, except the neocognition model can recognize patterns that are position shifted or slopes distortion. The cells are used for neocognitions are of two types: S cell, C cell. Cells that are trained suitably to respond to only certain features in the previous layer is called S cell. A cell dispatches result of S cell space, that is sum of spreads, the future recognized by S cell. Input layer, S cell, C cell, the different modules, S cell, C cell, another module 2, module N like this. This is a neocognition model. Neocognition net consists of many modules with layered arrangements of S cells and C cells. The S cell receives the input from the previous layer, while C cell receives the input from the S layer. During training, only the inputs to the S layers are modified. S layer helps the dedication specific features and their complexities. The feature recognized in the S1 layer may be horizontal bar or a vertical bar, but the features in the SN layer may be more complex. Each unit in the C layer corresponding to the relative position of the independent feature. For the independent feature, C node receives the input from a subset of S layer nodes. For instance, one node of the C layer corresponds to the relative position independent feature. For the independent feature, C node receives the input from the subset of S layer nodes. For the instance, if node is S3 layer detects a vertical line and four nodes are in the preceding S layer detect a vertical line, then these four nodes will give a input to the specific node in the C layer. Just try to understand. In a specific distribute of the extract features. In the extract features. Hello. Sir, namaste. Neocognition networks of two layers with different nodes, and though nodes are composed of S and C layers only. Okay, neocognition networks of many modules with layered arrangements of S and C cells. The S cell receives the input from the previous layer, while C cell receives from the input from the S layer. That is most important. I'm posting here. In the chat box. This is important line. For that's only I'm doing analyzing and interpretation. మనం వీటిని ఎంత అనాలిసిస్ చేసి ఇంటర్ప్రిట్ చేస్తే సీక్వెన్స్ ఆఫ్ నాలెడ్జ్ అంత బిల్డ్ అవుతుందండి ప్రాక్టికల్గా. నా ప్రాక్టికల్ ఎక్స్పీరియన్స్తో మీకు అన్నీ లింకప్ చేసి కాన్సెప్చువల్ ఓరియంటెడ్లో పెడుతున్నాను. మళ్ళీ మీరు ఫర్దర్గా దీన్ని కాన్సెప్చువల్ యాడ్ చేసుకోవాలి. నేను చెప్పిన దాన్ని జాగ్రత్తగా యాజ్ ఇట్ చదువుతూ దానికి కాన్సెప్చువల్ వేలో థింక్ చేస్తుండాలి. టు బిల్డ్ ఏ గుడ్ నాలెడ్జ్. That is very important sentence, of course. Here, during the training only, inputs to the S layer as modified. S layer helps in the detection of specific features and their complexities. The feature recognized in the S1 layer may be horizontal bar or a vertical bar, but the feature in the S1 layer may be more complex. S1 layer feature is very complex. Each unit in the C layer corresponds to relative position to the independent features. For the independent feature, C node receives the input from a subset of S layer nodes. For instance, if one node in the C layer detects a vertical line in the 4 nodes in the preceding S layer detect a vertical line, then these 4 nodes will give the input to the specific node in the C layer to specially distribute the extracted features in the modules present near the input layer, lower in hierarchy, will retain before the modules that are higher hierarchy modules obtained before module 2. Okay, when you go to higher layers, it is very complex. The users have to fix the receptive field of each C node before training starts, because inputs to the C node cannot be modified. The lower level modules have smaller receptive fields, while the higher level modules indicate complex independent features present in the hidden layer. Cellular neural network. Another concept is cellular neural network. This is very important in the practical application. Cellular neural network is introduced in 1988 only. It's based on cellular automation. That is every cell network connected only to the neighbor cells. As you see in the figure, Then I cell C1 comma 1 in the matrix C1 comma 2, C2 comma 1, C2 comma 2. It's a 2 by 2 matrix. When you go to the 3 by 3 matrix, C1 comma 1, C12, C13, C21, C22, C23, C31, C32, C3. This is the 3 by 3 matrix of the computer neural network. Once you examine, even if the cells are not optically connected, they are not directly connected with each other. They affect each other indirectly due to propagation effects of the network dynamics. The Sergio neural networks can be implemented by means of hardware model. This is achieved by replacing each cell with linear capacitors and resistors, linear and nonlinear control circuits, and independent sources. An electronic circuit model that can be constructed for a cellular neural network. The cellular neural networks are used in a wide variety of applications, including image processing, pattern recognition, and array computers. Their applications. Okay, they are used in these applications frequently. This is hello, sir. Mr. Only. So this is a concept here. These applications. Optical neural networks are interconnect neurons with light beams. Owing to this interconnection, no insulation is required between signal paths and the light rays can pass through each other without interacting. Okay, the path of the signal travels in 3 dimensions. The transmission path density is limited by the spacing of light sources. The divergence effect and the spacing of detectors. As a result, all signals pass or operate simultaneously. And true data results are produced. Holograms with high density, the weighted strengths are stored. These are the weights modified lining producing fully adaptive systems. There are two classes of this optical neural network: electro-optical multipliers, holographic correlators. Electro-optical multipliers. Electro-optical multipliers are also called electro-optical matrix multipliers perform matrix multiplications in parallel. The network speed is limited by only the available electro-optical components. Here the computation time is potentially in nanoseconds range. A model of electro-optical matrix multiplier is shown in figure. Figure shows a system which can be multiplied 9 elements input vector by 9 by 7 matrix which produces 7 elements net vector. There exists a column of light source that possesses its rays through a lens. Each light illuminates a single row of white sheet. The white sheet is a photographic film where transmittance of each square is proportional to the weight. It is a net weight. Holographic correlators and holographic correlators, because there are two classes of optical networks. This is very important. Electro-optical correlate multipliers and holographic correlators. Like this. Electro-optical multipliers, also called as electro-optical matrix multipliers, perform matrix multiplication in parallel. Whereas holographic correlators, the reference images are stored in a thin hologram and retrieved in a coherently illuminated feedback loop. The input signal, either noisy or incomplete, is a concept in the holographic correlators. This electro-optical multipliers concept. Third generation neural networks. From that highlight concept is spiking neural networks. It is based on the fundamental biological understandings of the neuron in this concept of SNN. It's a concept here. These are artifices of SNN model. This is the neurons in central nervous system communicate using the short duration electrical impulses called spikes or action potentials, in which the amplitude is constant in the same structure neurons. Each spiking neuron is characterized by membranes of potential. The firing time of neuron is called spike time. The other neuron model is as the following equations. Okay, the parameter describes time scale. Parameter describes some sensitivity. The parameter describes the after spike. Parameter describes the spike of the power recovery. The SNN with the N neurons assumed to be fully connected. When the input current signal changes the response, encoding neurons in the SNN, spiking neuron network can be encoded digital and analog information. Neuron coding three categories: rate coding, temporal and coding, and population coding. This is the concept again. Learning with spiking neurons. Similar to supervised training algorithm, it is neurons characterized with sudden change of membrane's potential instantly. Potential behavior leads to complexity in training. Spike prop learning algorithm. As an employs spiking neurons are computational units. Spike prop algorithm, the threshold is chosen. Feed forward stage input cinematic receives. Perform the error back propagation learning. Calculate that function. Update the weights. Spike independent stop algorithm. This is spike algorithm is a quantitative form of Hibben algorithm. Combination network, convolutional neural network. Convolutional neural network is built up one or more number of convolution layers. One is fully connected feed-forward network. The neurons are arranged in three dimensions: height, weight, and depth. Figure shows arrangements of components of three layers: convolution layer, pooling layer, fully interconnected layer. These are the three layers. Okay, I explained more concepts. Okay, discussed more concepts. I to study asked is my thank you so much. Once again.